Okay, today we're working on section 6.2, solving these a little bit more algebraic than what we did in the past. So here we go with this. So what is the system of equation? A system equation is two or more equations. Okay, now they can be linear equations or they can be a quadratic. It doesn't make any difference. So it's two or more equations is all that a system is. All right, now two lines that are parallel in a system and never intersect, okay, then they are said to have no solutions. Okay, so they are parallel, but they never ever touch, so they have no solution. And two lines that lie on top of each other, of one another, when graphed on a system, they have infinitely many solutions. They lie on top of each other. Now, something that I'd like to work on again here is I'd like to make sure we understand how you can tell by looking at the equations what type of answer you'll get. So the first thing I do is I check the slope. If the slopes are different, then these two lines intersect. Okay, so if the slope is different, the two lines are going to intersect. That's all I need to check is once I get this, I know that those two things are going to intersect. So the next thing, I check the slope. What happens if they're the same? Then I check the y-intercept. And if they are different, then these two lines are parallel, no solution. And then the last possibility that I can come up with, I check the slope. They're the same. I check the y-intercept. They are the same. So that means these lines are the same. And that tells me infinitely many. Those two things are the same exact lines. All right, so that's how I work down through this and look. So that's what I'm looking at. So if I were to look at this particular problem that I have right here, all right, these are both in slope-intercept form. And the slope of this one is -5, and the slope of the second one is -1. They're different. So these will intersect. And that gives me one solution. Okay, so that's the trail that I follow on these particular problems. Now, let's look at a couple different things here. Let's go, and I want to actually I'm going to graph this one now. I hope so. There's this, and let's see here. There it is. Okay, so now I'm good. All right, so I have this particular line. I have this one. That's -5x plus 6. And I have another one that's y is equal to -x minus 2. And let's get this back to single page and let's make it full screen. Okay, so I have those two equations. All right, so let's graph this first one. Let's graph this first. So that means my y-intercept is -2, so I put a dot at -2. And my slope is -1. So I go down one, right one. Now once I get that all dotted out, just like we did yesterday, I'm going to actually draw this out. Okay, so there's that one. And now let's do the second line. And let's look at this one. This one, the slope is negative 5/1, and the y-intercept is 6. So I'm going to graph the 6 first, 2, 4, 6, and then negative 5/1. So 2, 4, 1, there it is. 1, 2, 4, 5, there it is. Hey, there's the intersection point. So now let's draw this line. I'm trying to get this all set up. There we go. So now I found out these two intersect right here at an ordered pair of 2 and 1, 2, 3, 4. Now all week this week, what we're looking for where these two lines cross. That's all that we're doing, and we're going to find that location. This location this time happens to be at 2, -4. And that's what we're going to continue to do with these. Now, this method, the graphic method, is pretty work intensive. Well, it's not necessarily work intensive, but I have to have graph paper. It has some limitations because I have to have exactly that point. Otherwise, it doesn't work very well. So let's look at some other examples about how to solve this. Another way is a substitution. Okay, the substitution property states that if x equals y, then I can put, wherever I see the x, I can put the y. Or wherever I see the y, I can put the x. Now, here's what I'm going to do here, is I'm going to look at these, and I'm hoping to see an equation like this one, because that equation says y equals. As long as it says either x equals or y equals, that's what I want. So y is equal to 3x. That means wherever I see a y, I can put a 3x. So I'm going to replace, I'm going to put this 3x right in here for this. Now the advantage to this is now I have one variable. That's all I have, and that's what I really, really want. I have, this is all in terms of x. So I combine those x's. I want to get rid of this 4, okay, but I want to leave the x. So I'm going to divide both sides by 4, -8. So that means my x coordinate is -8. Now, I'm going to have to figure out what my y coordinate should be. So at this point, I'm going to look at this, and I'm going to try to decide, where do I want to put this? Which one makes it look easier for me? And it doesn't matter which one. I can go top or bottom. Personally, I like this top one still, because it looks like as soon as I put that in there, I'll have my answer. So let's try that. Let's put this answer that I just got of -8, let's put that in for this x. So y is equal to 3 times -8. Well, that tells me y is -24. And there's that point. Okay, now this is much more algebra dependent than what we had in the past. The other one was totally linear. We can end up putting this, graphing this quick and easy. But this is going to ask me to actually do some different things with this. And so let's see about the next one. This one, it says y equals again. So I'm going to put this in for here. So I have 2x plus 7 is equal to x minus 1. Okay, now the goal for this is I want to get all my x's on the same side. So what I'm going to do is I want to try to get, and I can choose, it doesn't make any difference. The goal is to get all the x's on one side, all the numbers on the other side. So I'm going to I always pick on the x's. And I always choose to move the smallest one. So I'm going to move this x. And I'll subtract it from both sides. So I get x plus 7 is equal to -1. Okay, good. So I got the x's on the left. Now let's get rid of this 7. So let's subtract 7 from both sides. X is -8. All right, so now I have -8 equals that. And again, now I get the chance to choose. Where do I want to put this -8? Do I want to put it in the top equation or the bottom equation? Well, to me, this bottom equation looks more simple. So I'm going to try that. So I'm going to put the negative 8 in for the x, and I'm going to combine. And let's see here, plus negative, so that's negative 9. So there's that answer. Okay, now, hey, every answer for x isn't negative 8 all the time. So this is what we're working with this. So now let's look at this next problem. And okay, now this one, it's not set up very nicely for me. I really don't like either one of these two, but I do see this. And that gives me some hope because that looks a little bit easier. So let's get that y all by itself. Ooh, see, when I look at this, but this top, ooh, I'm going to do that anyway. So I'm going to add the 2x to both sides. So I get y is equal to 2x minus 3. Okay, so now I can put this value in for these y's. So 3 times 2x minus 3 plus 4 times 2x minus 3 is equal to 14. Okay, next step. I really don't like parentheses, so I got to get rid of that. So let's multiply this thing out. And let's multiply here. Okay, so far so good. Now, I don't combine like things because this is awfully long and confusing. So 6x and 8x is 14x. Minus 21 is equal to 14. I got the x's on the left, so let's move this 21. Let's add it to both sides. Okay, so far so good. Let's divide everything by 14. Oh, what goes into 35 and 14? Well, 7 does. Goes in there 5 times and 2. Okay, so that was a lot of work for 5 over 2. My x-coordinate is 5 over 2. Now my y. Well, at this point, I'm kind of disappointed. My y is not too hard to find. If I look at this equation, it doesn't have any x's in it. It's just got y's, so let's add those up. 7y is equal to 14. Divide both sides by 7. Y is 2. All right, now, this one, that kind of makes me feel silly. Because if I would have done that, I could have put this 2 right in for this one right here. And maybe that would have made it a little bit easier. But that's not my pattern, so that's why I'm kind of stuck there. I didn't look at the problem very well to figure out an easier way to do it. Let's look at the last one I have here. Now this one again doesn't play very nice. It looks like I'm going to try to get this x by itself. So let's subtract 3y from both sides. Okay, so now let's put that in for this x. Yeah, I changed this one to 10 because that other number doesn't work very well. All right, I don't like parentheses, so let's get rid of the parentheses. No, I'm doing a video. Now let's combine these two. Let's add the 35 to both sides. Divide by negative 9. I got a y value of negative 5. Okay, so now let's look at this. I feel like I want to put that negative 5. I feel like I want to put it in here for this one. It really doesn't make any difference, but this is a little bit smaller, so let's try that. 3 times negative 5 is equal to negative 7. x minus 15 is equal to negative 7. X is equal to 8. Here we go. That one worked out all right. So really, that third one's the only one that we got a goofy answer. But there we go with this. This is what we're doing. This is called the substitution method. Now you have an assignment on Canvas for you to do after this. So that's what you guys are supposed to. That's what you're supposed to work on, completing that. Okay, that's it for today.